Hi, so it looks like I am broadcasting now. So, hello everyone. That was a lot of fun last time, but I think that was a little rough because I didn't really have anything prepared and I didn't give people enough notice that the show was going to be starting and give people a real chance to join into the Q&A section, etc. Well, this time I've had some specific requests that people gave me before I even started the video, and I will do my best to cover each one of those in a decent amount of depth. To begin with, the very first thing that I was asked was to talk a little bit more about what I had written on why probiotic cannabis has greater perceived strength. So first off, I'd like to start the video by saying that this is a working motive mechanism that I would like to see researched further, and until then, this is pretty much just my own research and my own ideas that I have a whole bunch of peer-reviewed journals behind it that I can share with people that are where the ideas come from, and they're kind of something you can see a growing trend of when you read a whole bunch of them and you start to see the way that it's acting, and then you can do your own experiments at home and pretty much show yourself how a lot of these things are working and make it a little bit simpler for yourself to understand the deeper sciences behind cannabis. But to get on to what I was asked, I went ahead and grabbed a copy of the paper in question so that I can actually know what exactly I'm talking about when I reference a specific paper, or maybe I reference a specific visual. If you would like to follow along, you can go to moderncannabis.com, and under advanced knowledge you will find a small button that says mode of action, why probiotic pot is stronger. And then underneath that, you'll see mode of action for the increased trichome/calyx ratio, as well as increased strength of probiotic cannabis. Now, to start with this, you're going to need to know a little bit about fatty acid biosynthesis inside of the cannabis plant. Now, if you've never gone over this before, when we talk about fatty acids, what they do, and when we talk about really any trichome structure, we're talking about specifically a capitate trichome structure. We're trying to have a storage mechanism. There are non-capitate trichome that are less important to us, and when you do research stuff about trichomes, do really hard, try to pay a lot of attention to that. Sorry for the little slip up there. Try to pay a lot of attention to that, because when we talk about a storage and secreting glandular trichome, we are talking about something very specific. And even more specific, we have cannabis, which is making terpenophenolic compounds. So you have a terpene being produced in a vacuole and phenolic compounds being produced in another vacuole. And it is repeated, some parts of that, in other plants. So there are other bits of research that you can't take directly from, but you can find things that you can research deeper about, or do experiments on yourself and try to find out what the similarities are or what they're not. And in doing so, if you do any of those things, please post them to the community. We do need more people sharing as much experimentation as possible. There is no one right way right now. I don't think there ever will be, just with most styles of growing. But if you're not familiar with why I say glandular trichome, there are non-glandular trichome. If you're looking at that, you're usually looking at Arabidopsis, and these are single-cell non-glandular trichome, and these are not important to us at all. Like, though we do have mixed trichome on cannabis itself, the stalks are not important. The heads are what are important to us. We're looking at something where we need both of those vacuoles present to create the cannabinoid mat that we are desiring, whether that be a CBD dominant or THC dominant, doesn't matter. You do need that head. I have, if I remember correctly, I remember something that Steve Hill put up way back in the day about CBD having a larger amount of a specific type of trichome, and I'd be interested to know if there's any work out there on how the fatty acid biosynthesis pathways play a role in that, like where exactly it basically ends up creating a larger amount. Because when you're looking at the biosynthesis pathways, if you're looking at the most simple sense, you're usually going from geranyl pyrophosphate and olivotolic acid into cannabigerolic acid, which then will go to the you either have tetrahydrocannabinol synthase, or you have cannabidolic acid synthase, or cannabichromic acid synthase, and that's a CBCA if you're not familiar. When we talk about that, I always have wondered why it is that we really do see these predominant traits. I mean, it's more simple when we talk about, like in the last video, the whole THCV versus THC. I mean, that's a whole change of olivotolic acid to diveronolic acid. And because of that, we see a whole different trichome. Now, since this is just going up one step with geranol pyrophosphatase, olivate, geranol transferase enzyme biosynthesis, switch up to cannabigerolic acid, the CBGA. The next part is the synthase to these diverse cannabinoids. I haven't seen a lot of work yet. Maybe there is something a little bit deeper in the work United Pharmaceuticals put out in terms of peer-reviewed science, because I don't super care for the rest of their work, but their science is really spot on. I would be interested to know what enzyme is occurring at a higher amount, if those enzymes can be affected by just genetic or epigenetic factors. And really quick, speaking on that, I'm sure a lot of you guys have come across any more breeders talking about, is this an epigenetic plant? Is this bred epigenetically? And even further, if you watch the Adam Dunn show, I watched a little bit of the last one, which was the breeder special, and it was really good. There was a lot of very, very smart people there, and one of the people that I was really enjoying listening to was their geneticist, and he mentioned that he was using shotgun sequencing to make a genetic roadmap of cannabis. Now, this is something I find incredibly fascinating, very, very, very fascinating, but it's fascinating for a multitude of reasons. And one of them is I'm curious if we're going to end up with this kind of like reductionist view, because when we look at something from shotgun sequencing, we're going to start looking at it basically as the number of alleles that are different, the number of traits that are changed, and the amount that are common and where that divergence is. But only recently in overall the study of genetics have we started to go into epigenetics, which is things that aren't actually changed at a DNA level in terms of like code change, but can be anything from like histone modification. There's a whole set of things that come under epigenetics. It's very diverse, and we're increasingly finding that the type of medicine we were using was a little bit more extreme, I guess, compared to some of the newer treatments that are being shown as very valuable and a very viable way of moving forward when looking at epigenetic factors. When we look at epigenetic factors, even inside the human body, the regulation of inflammation and irritation in something, kind of simple and silly, but as irritable bowel disease, which, tons of people have, that can be completely downregulated to the point that people no longer feel the conditions from it, from epigenetic factors, and that's taking like Lactobacillus plantarum and Lactobacillus acidophilus cultures. And there's a whole paper on this. If you look up the relation of epigenetic factors in the internal gut lining with our overall health, it's absolutely fascinating. And of course, this has kind of come to more of a rise in popularity over the last like 12 years. It's become a really in vogue subject of genetics. But we're just now starting to get to the point where we're understanding enough about epigenetics that we might have the ability to one day start to make kind of an epigenetic roadmap, which I guess would be a little bit more like potential pathways, or if you've ever read like a choose your own adventure book, how there's so many different choices. I mean, there's a huge host of things that are being shown to upregulate or downregulate epigenetic factors. And when we talk about that, I wonder if the same thing is going to end up being as prominent in cannabis. When I listened to that last show, I remember specifically that I think it was JJ from Top Dogs was discussing that he didn't care for the way we hold titles on cannabis right now. The whole, is this AJ's cut of sour diesel, et cetera, if it's sour diesel was his main point. And I can definitely understand what he's saying, but when we look at something like epigenetics and how a plant was handled and how many times it's been cloned and how it was cloned are going to affect such a huge thing. that's really going to change the plant that you're getting. I mean, not only from viability, from terpene, to a whole host of factors. So now we start, kind of questioning how much does this actually play a role, and if it is as prominent as genetic factors, like it's seeming to point to with humans, aren't we kind of going to need to do that just as much as we need the original genetic roadmap, which I suppose will kind of serve as a foundation for that type of further research, hopefully. But if we show that and we know that, it's going to kind of change the reason why we have these labels. I mean, if you have someone who's had a cutting of something, it's the second cutting that ever came off the mother plant, he's kept it absolutely, babied and loved and increased all of its systemic acquired resistance and, done everything that could be good for the plant, it's going to show a whole host of epigenetic factors that have been changed about how it acts and how it can handle things and what it's going to pass on in progeny than, say, some dispensary cut. So all of a sudden, that label is pretty important. And that's just something I kind of hope that we research a little bit further here with cannabis, as the ability to becomes a little bit easier. I know that there's a lot of forms of shotgun sequencing that actually allow you to easily document like histone modification and all that type of stuff. So there's a really good chance that that guy's already thought of this and he may already have all this planned. It's just something that came up when I was listening to like the first 3/4 of the show before I got distracted with something around the house, as I often do. But back onto that original subject, sorry to have a little bit of an aside there. I'm kind of tangential as a person. But we were talking about biosynthesis, and we were talking about, why this makes an impact with probiotics specifically. So we talked about before how it's going to go from olivotolic acid and geranyl pyrophosphatase into the cannabigorolic acid. Sorry, we got a little bit of a I don't quite get it all out correctly the first time. Cannabigorolic acid. And from the cannabigorolic acid, you have your synthesis into THCA, into CBGA, into CBCA. So CBDA. It's already at CBGA. So this is a really important thing to know. This is really deeply and at a very base how a lot of different things happen, and that's not just cannabinoids. This is terpenes as well, because we're looking at, like I said earlier, terpenophenolic compounds. And if you're not familiar with terpenes, one second. And those are a type of biochemical compound that are generally described as being hydrocarbons. But in a more complex thing, we can think of them as all being derived from the same basic C5 building blocks, isopentenyl, if I remember correctly, isopentenyl diphosphate, IPP, and a few others. I think it's like one other thing. I think it's DMAPP. But both of those are the basic building block for most, right? So in addition to multiple isomers of the simple mono C10 and sesqua and mono di sesquiterpene, they also have very similar backbones. They will be usually, we see a lot of them just from oxidation cycles, from isomerization cycles, and a fair amount from just like conjugation with moieties. So they're a pretty fascinating thing. They're what describe the smell that we're getting from a plant, and that's a huge deal. It used to be that we kind of thought of this as something like, oh yeah, it affects some of the high. Well, it's so much beyond that. We know now that we have factors like the what's that show? It's called the entourage effect. There we go. And when cannabinoids come through with specific terpene structures, they have this thing called the entourage effect, and they basically affect one another in a very diverse and very complex set of ways. Like, we're just now getting to the point where we're seeing that, and this is something that Jim Freer brought up to me, so I want to totally give him the shout out on that, because he did a really good paper on it, and if you message him about it, maybe he'll share it. But it was on the binding of CBD to our CB1 and CB2 receptors inside the endocannabinoid systems, and how the one of the terpenes that makes up what we smell very commonly, like in black pepper, this beta myrcene, if I remember correctly, I'm pretty sure it's beta myrcene, might have that off, but I feel pretty confident with that. But it assigns at 12 times the potency, or 12 times the affinity level, that's the word, that CBD does, and it accomplishes a lot of the same effects. So now we're starting to see this trend of like, well, you can get some pretty pain relieving effects from plants that don't seemingly have high CBD. And now we're starting to see mechanisms for that. And this is the same as, you smoke one of the more old school plants, or the lavender plants. They generally don't have a super high THC rating, but they have a lot of linalool, which helps permeate the blood-brain barrier, so you feel it much more prolifically. So the way that we viewed cannabis for a while was kind of like reductionist. These terpenes are way more than just a modifier. They're the substance of the high. It's why we can have something that has exactly the same ratios when we look at them of like THC, CBD, and some of these secondaries, and they're almost, polar opposites, or, very different highs. I mean, I've seen, sativas that are super high THC, and I've had OGs that are super high THC and don't necessarily have a lot of CBD. And with such tiny degrees of change, you have almost 180s in plants. And we're starting to see why. Now, these fatty acid biosynthesis, this occurs to terpenes as well. So this is important for more than just, your plants. Cannabis, this is important for really all of your plants when you're trying to produce the most out of them that you possibly can. You're trying to get all of the, phyto terpenoid structures that will come to that plant that you possibly can. So when we do that, there's, generally speaking, like if you just threw a plant outside, we all know that there's a point in the season that you begin to get, more near red light or far red light, and it begins to cause that changeover into flowering. And it's around then that you usually get a lot of the more prolific odoriferousness and more of the trichomes being grown out and all that. And we can kind of not jumpstart that entire flowering process, but we can jumpstart the fatty acid biosynthesis and begin to get, sets of energy and sugars available. And you'll notice when you do this a lot that a lot of your plants begin to develop this sort of short, stubby trichomes that form even in veg, like kind of all over the stalk. They're really, really small. They remind me a lot of it's like wild tomato plants and stuff like that, where you see that they have just that fine level of trichomes coming off the outside. You start to see more stuff like that. And right now, my hypothesis for that is that you're beginning to see more of like the acyl sugars and stuff like that begin to be ready over in the stalk cell before the actual head is built. And this gives us the potential for getting more cannabinoids more evenly across the plant. Like, we might not test and find it stronger, but you would be able to test from the top and the bottom and find a much more average strength. And when you end up with more of these, actually always all these trichomes actually hitting their genetic marker of where they could get to, and you have a higher amount of them on the calyx, when you're still getting more cannabinoids. I mean, it doesn't have to be just a higher percent. The amount that is on the surface that are being vaporized are obviously going to increase. So you're going to end up with a higher perceived effect. And you're also going to end up with more terpenes, which, like we just talked about, you're going to end up with a higher effect. So now that we've kind of covered that and why the biosynthesis is important and why it's going to impact the plants to make them more favorable and make them more desirable, let's talk a little bit deeper on the science behind that. To begin with, I mentioned before in the last video that you are looking at, with EM1, hexonic acid. And when, more specifically, you're looking at let's see here, hexonic acid, which is sometimes called caporic acid. Now, this occurs in a lot of different things. It occurs in the outside of seeds of ginkgo and kind of gives them their unpleasant smell and odoriferousness. And they're also found in like ruminant milk fats. They're found actually pretty high amount in breast milk, along with, the endocannabinoids of the body. So it seems like there's a pretty high amount of affinity between where the two are shared. But on a more specific level, when we talk about this, we're talking about, milk triglycerides and milk fats. we are using when we make EM1, you try to go for generally the best, most raw milk that you can possibly get. You're trying to find the highest amount of fat. I know that where I live, I don't have like a lot of dairy farmers or anything like that. So the best I can generally do is going down to like one of the nicer health food stores, and they always have like the cream on top ones that are still thick, and I'll use that stuff. I'm lactose intolerant, so I don't drink any of it myself. And you're having higher amounts of milk sugars processed, which ends up in higher amount of lactic acid, which, if you'd enjoy a quick aside, if you are having a hard time remembering like lactic acid and all those different types of things, an easy way to think of them is when we think of food. We describe a lot of food as acidic, but there's a lot of different acids that actually comes from, that perception. And this can be anything from citric acid, which is like oranges and lemons. This can be malic acid, which is like apples, tartaric acid, which is grapes, wine, all that kind of stuff. You have fermentation-derived acids, like acetic acid, which is vinegar, butyric acid, which is cheese, lactic acid, yogurt, phosphoric acid is soda. So there's a lot of different forms of acidic, and it's really important to know that. So when these bacteria continually like consume these sugars and produce these acids, we end up with some of the fat is always kind of like left over. There's a huge difference if you've ever seen a Terraganics EM1 versus homemade EM1. It looks very different. And that's part of why I really highlight that homemade EM1 is the best way to ensure that you are actually going to be getting a high amount of ruminant milk fats. So these ruminant milk fats contain, I think it's like 2 to 3%, 1 to 2% of the total fatty acid content that we're looking at, that zoolic, that hexonic acid. And when the hexonic acid acts with acetyl-CoA, which is coactive enzyme, acetyl-coactive enzyme, you end up with hexanyl coactive enzyme and malonyl coactive enzyme. And then there's a somewhat, for the moment, an unknown polypeptide synthase that happens upon that specific coactive enzyme that ends up into a levitolic acid. So if you look at like a lot of these old biosynthesis papers, you'll notice that a lot of them just kind of start at a levitolic acid and geranyl pyrophosphate. This isn't correct. Like in the last probably, I think it'd be in the last 8 to 10 years, the studies have actually begun to go into a greater depth, and we start to see the acetyl coactive enzyme being reacted upon. Well, I guess it's not the correct term to say being reacted upon, but going under biological synthase, and you end up with the 3-malonyl acid coactive enzyme and the N-hexanyl coactive enzyme. And then from there, you have an unknown polypeptide synthase, and you end up with a levitolic acid from that malonyl and hexanyl, and then you have your geranyl pyrophosphate. And then both of those are basically have further synthesis upon the enzyme that's a prenyl transferase enzyme, and you end up with cannabigerolic acid. This is CBGA, excuse me. And that's pretty much the start of where everything we want is. Like once it's to CBGA, everything from there is the synthase into all the stuff that we find useful, where we can get rid of the acid group through decarboxylation, which again, if you're not familiar, the carboxyl group is COOH. When we do decarboxylation, we end up losing this group as water and carbon dioxide. So like a little bit of moisture and carbon dioxide, oxygen and carbon dioxide, excuse me. Yeah. But yeah. So I suppose you do get a little bit of moisture with it as well. That's part of the hydrogen OOH, yeah. So that's correct. When we do that, that's part of why we've talked about before, if you've read any basic Grow Bible, they've talked about why the decarboxylation is completely important. And now you're starting to see it to the point where people only think about it really with hash making and stuff like that. And edible making. And that's kind of disappointing, because part of the reason we saw this huge lowering of quality that became more standard as we commercialized was that a lot of stuff was not being cured at all. Like at all. Most dispensaries have done walkthroughs that you don't really see many that do curing. This is part of why we see this hugely lower quality. part, not the entirety thing at all, just one small subset of why we see such lower quality in commercialization than we do in a home grower who knows what they're doing and actually, like, takes care of their plants. So please don't forget to properly cure your plants. Try to give it at least 6 to 8 weeks to get rid of all the carboxyl group. And when you do it that way, you'll end up with degradation of chlorophyll in a very slow, safe way. I think it attaches to some of the hydrogen. No, I can't do that. It must be breaking down into a further acid. I'll have to look into that and let you guys know. But when we look at THCA synthase, you end up with tetrahydrocannabidiolic acid, this THCA. From there, we can technically see a lot more stuff happen. There are a lot of secondary cannabinoids that occur from oxidation of these original carboxyl heavy or acidic cannabinoid groups, and that's pretty interesting. We also do see a certain set of them that don't exist past that first little bit, and this kind of gives rise to why we see such a difference in not only potency but kind of type of high when we do stuff like fresh frozen versus people who've let their trim or cure sit out. I guess really no one really cures their trim that I know of, but just drying it, even, you're going to have some loss of these carboxyl groups, and since you're using a solvent that doesn't pick up chlorophyll as heavy, it's not really that big of a deal for quite as long, because part of the reason we do it at a longer rate is that breakdown of chlorophyll and chlorophyllic acid, because otherwise it's very harsh and peppery at the back of the throat, and if you're a asthmatic like me, this is a pretty big deal. It can make me I might be able to smoke like a bowl or two, then all of a sudden just my throat hurts for the rest of the day. So we do that for a specific reason. When we look at stuff like BHO or one of the other ones where you're using a selective solvent, you are using something that doesn't pick up chlorophyll quite as well. I mean, it will definitely, if you do things wrong, if you have a high amount of water still in it, it definitely can. And obviously there's some other fine points to that. I'm not an extract artist by any means, or whatever they call themselves these days, but I'm not an extract person. I just like to read about things. So we kind of covered the whole hexonic acid to hexanyl CoA to olivotolic acid. I've said before, and if it wasn't clear, olivotolic acid is where at that point you're going to be starting to break down into, or rather synthase into cannabinoid acidic cannabinoid groups, and from there it's pretty much like all the stuff we know and we like. So we talk about like UVB light stimulating further cannabinoids. It's because UVB light stimulates higher production of olivotolic acid. So when you start doing higher amounts of UVB light and you're doing EM1 that has high amounts of ruminant milk fats to get earlier and higher production of hexanic acid, and you're doing, there's actually a few species of bacteria that we've begun to find have actually excrete some of this hexonic acid, and there's a few of them, or rather two, in modern microbes, which is part of the reason why people who have been using it have been finding higher trichomes, higher terpene, higher cannabinoids. So it's pretty amazing what bacteria can do and how this will allow for you to have a much simpler time growing. Things will feel much easier than we were making them before, and it's pretty cool. I feel like that kind of covers it to the best that I can in a short video. So real quick, I'm going to see if people have had any other requests for things for me to cover, and if so, then I'll cover those, and if not, then I will go over some other stuff that people asked me earlier in the Probiotic Farmers Alliance thread. So it looks like I have no new questions. So I was asked as well, can you go into exactly what can be used for fermented plant extracts, as far as root powders, rock dust, any of those types of stuff? All right, yeah, totally. I can definitely go over that. I'm very happy to. When we talk about fermented plant extracts, we are talking about any type of botanical extract that can be fermented that is non-microbial. So you will want to look up basically if it's, antimicrobial in any way, because if it is, generally speaking, you're not going to want to ferment it and give it to your plants. There's, exceptions to every rule, but in the majority of times, this is what you're going to find to be the most useful. When you're doing fermented plant extracts, we've found that fruits and veggies are wonderful, especially squashes. Gourd plants really contain pretty decent amounts of magnesium and phosphorus. Fruits are really good on tons of things. We talked about before, please don't use citrus because it's very antimicrobial. Uh, which, kind of on an interesting note, I would be curious if any of the viewers who watch this, one of the things that I've always noticed when you grow in a plant that's very scented, very orange, and you have this high amount of citrine and I can't remember, limonene and citrine and a few of the other ones that we know have more of an antimicrobial effect. I wonder if that's part of why they seem to have a harder time getting powdery mildew or any of those types of invasions, is they are slightly antimicrobial on the surface while growing, which is kind of interesting. I don't know, just something to see if any of you guys have any further information on. But with anytime you're doing a fermented extract, now we haven't done a lot of the rock dust ones. I've seen people do it in the past, but I've never seen anyone post that they've used that fermented extract that contained heavy amounts of rock dust. Now, we have seen the ones that are stuff like eggshell, where you take eggshell and put it inside the oven at like, I think it's 45 degrees or 145 degrees or 210 degrees, something like that, and you bake off all the albumum and anything remaining like that, and then you crush them all down and put them in a jar with a small amount of vinegar, and after a certain amount of time you end up with a calcium solution. Now, I don't use that myself. I tried it a little bit, but it's way too acidic for me, and I find that continually top dressing calcium soluble things, my plants are super happy. I don't have any issues. I don't end up needing the calcium supplements. That's what's worked for me. So I haven't trying to take that to a further level because it didn't do what I was looking for in the first place. I have done a lot of fermented extracts. I really do like them. They're especially good for IPM if you're doing stuff like garlic and cayenne, stuff like that. But when it comes to roots, I would generally put them into a bokashi bin just because you are going to end up with that nice high lignin compost. So you'll end up with a higher ability for you to do stuff like mushroom compost, or if you want to end up with higher mushroom amounts, you can take some of the spores if you have like decomposing logs out in your backyard and take some as compost and put it near there, and you'll see pretty quick that you'll end up with freaking the mycelium will take over that bit, and then you'll end up with mushrooms fruiting out the side. And mushrooms are actually something that's kind of cool to talk about. If you have a mushroom that's considered an edible species, now this is very specific, if they are edible species, ferment them and give it to your plant for sure. Any of you people who have an edible species of mushroom in decent amount near you, enough that you could do, a bottle of it, check it out, see what you think, keep us all updated. Good stuff. The metabolites that are made inside mushrooms are pretty amazing, definitely. Now, to cover, I think there was another question that someone had posted inside the other soil group that I'm in. They asked about isolation of microbial life, right? Now that is a very big topic, and there's a lot that can be said on that. So to cover it to any depth and really not try to gloss over too much, I'm just going to cover the ones that most of you guys as probiotic growers would encounter. So first off, if you do end up using Grokashi, which again, I highly, highly recommend, if you use too much of it, you can find that all of a sudden the pseudo-hyphae mass is beginning to go gray or black. That is bad. If that happens, scoop out by 2 feet by 2 feet around it, and go put that in your hot compost bin. Make sure it gets to a very hot temperature. It can happen. I've done it, so careful about that. Don't overuse. The directions are spot on. With other things, like say you're making like EM1, you do a carbohydrate wash. That's why you wash rice at the beginning. When you do a carbohydrate wash, you've made it something that pretty much any bacteria can just go feed off of. So it's very easy if you keep a dirty house, or you try to do things out in a garden that hasn't gone fully probiotic yet. So there's a lot of indigenous microorganism there that are better at out competing than the ones that we're looking for. You can definitely see some really weird stuff inside this when it makes its its solution, and even into the fermentation with the milk. We've seen some pretty weird ones, actually. We had to throw away a huge amount because we kept trying to do it up in one of these really old cupboards for a while. And for whatever reason, no matter what, even when we just set a timer and followed exactly what they say on every single one, we'd end up with like grayish black contamination. And so I went through and cleaned out all of the cupboards with like hydrogen peroxide, and then did a super, super light spritz with EM1, and it's never happened again. So all good now. If you do find that happening, maybe that'll work for you as well. I hope so. I don't think that there's really too many other microorganism situations where you're gonna be finding contamination. The only other things that we've done that you learn from is letting SSTs sit too long. Oh man, I have come back to barley that has begun to mold on the inside a little bit. Some that smells a little alcoholic. Pitch it pretty much just all the time. Just pitch it, get rid of it. Let it go. It's fine. On the subject of anaerobic fermentation, real quick, if you're using insect frass, check out their website. They have a section that says how to use frass, and under it is I think it's 3 hours that you anaerobically ferment, and this is specifically for higher amounts of chitosan oligosaccharide, and this is hugely useful in your IPM. What this does is it dissolves the outer membrane of a lot of types of the soil-prone microorganisms, or bugs that we don't like. It will make bugs that we don't like. It will make their eggs just lose their outside lining. And once you've done that, you wait until the next watering, and you water in nematodes. And nematodes will now go through and puncture those little eggs and inject their enzyme and liquefy it, and then drink it all up. And then they end up with fatty acids in your soil that are good. So look up beneficial nematodes. Make sure you're using those in your garden. If you're not, your plants will be happier. You'll be happier. And once you get on a nice schedule with it, I like to do more nematodes into my soil about every 2 weeks. But that's just me. Whatever you find that works for you, that's awesome. The more you encourage life in your soil, and you find that you can get it to find a sort of communion. I'm not thinking of the word consortium. There we go. When they start to form a sort of consortium, you've begun to get in a good schedule, and this will happen way sooner than you expect. It's pretty impressive. I did just mention IPM, and I noticed that actually I didn't mention that in the last video. So IPM, that's Integrated Pest Management. If you're wondering how we as organic growers end up not having to use pesticides, fungicides, you name it, it's by staying on top of preventative. Because as an organic grower, we can win the battle if we are preventative and don't need to be curative. There are ways to take care of things curatively that are still organic, but generally speaking, if you want the best quality you possibly can, this is something you're avoiding. So do quality pest management. And a good IPM program means spraying down your vegetative plants with essential oils are incredibly useful. Microorganisms of different type are incredibly useful. Like we just talked about, the anaerobic ferment of insect frass for the chitosan oligosaccharide is incredibly useful. All of using those together is going to make a very huge amount of difference. If you end up seeing something or if you're getting clones in from someone, also add neem and karanja oil. Make sure you use something for saponification to make sure it's evenly mixed. Make sure your water is warm enough, and that's a very important part. Make sure your water is warm enough. Continually use a silica product. Now, some people perform silic acid. Some people prefer some people prefer silic acid. Some people prefer Agsil. I'm using Agsil at the moment. I've wanted to check out silic acid a little bit, but at the moment I haven't found a way to do so that is within my standards of how I garden. I'm trying to look a little bit into gestation of Agsil with silica solubilizing bacteria to produce high amounts of silic acid, but until I've played around more, I can't really say anything further on that. But for the moment, if you don't have silica in your garden, go to buildasoil.com, grab some AgSil from Jeremy. He's got great stuff, great prices. Use this every foliar, and honestly, like, we go pretty much every watering with silica at this point, except for anything past like week 6 in flower. I think was right around when we stopped for an average 10-week plant. If we're going for 12 or 14, then it'll go to 7 or 8 weeks, of course. But the main point is you can use this every watering, and it is incredibly useful. It's going to make your plants healthier. You're going to get more from them. It's going to make them harder for pests to take a hold of. It's a really big deal. Definitely check it out. Look into it. We actually have a full IPM section on the website over at moderncannabis.com under modern methods. That's the full IPM that we use, and it even includes the situational neem and karanja oil. So if you're unfamiliar with integrated pest management, it's never a better time than now to become acquainted. I believe that Jeremy has a IPM package, or kit, that's the word, is an IPM kit being sold right now that's really, really good. If you do end up with something that your IPM didn't quite get it, or you're just getting onto IPM and you're trying to fix a problem, then check out Big Time Exterminator from Austin Sherman. So definitely check that out. I don't use that in my normal IPM, but I do use it on all the new incoming clones, anything like that. It's completely safe. It's really good. It's great stuff. Works very well. Use it at the rates that it says on it, and it will work very well. So something worth checking out. Now, I don't believe we have any further questions. The Q&A here so far did not get any, and I have answered all the ones that were on the Probiotic Farmers Alliance when this started. So I'm going to take a moment to just kind of re-explain a few things that I may have mispronounced or kind of glossed over last time. But specifically, I did mention at one point kind of talking about what they use when they're testing similar trichome. And the correct plant for that was specifically wild stress, wild. I gotta find it in the article because I'm not gonna just remember it. It appears. I apologize for that, everyone. I tried my best to pull it out, but I did not manage to. But it's a type of wild tomato that is stress tolerable. That's the word. And it has a very, very similar type of glandular trichome to cannabis. You guys may have in the past kind of seen cannabis plants that have burst a trichome. You end up with like that little sticky bit of like that little sticky orb coming out the end, or maybe it's gone full busted and it gets on the plant, and you end up with spots that are all super sticky, and they start to break down some of the chlorophyllic acid at that spot. It's kind of interesting. Sometimes you'll notice like slight discoloration in the green right there. Now, when we talk about stuff like that, we're talking about something that was also tested on exactly that plant, and that plant was the Solum pinelli, which is again stress tolerant wild tomato. There's a bunch of other species that also fall under this type of trichome structure. I mean, datura, tobacco, all of those. But you're basically having a glucose and sucrose that are acylated. So you end up with 3-4 acyl groups of both straight and branched chains, ranging from different amounts of carbon on them. Now, this is like really interesting because you end up with a kind of a unique form of sugar. This is considered a polyester acyl sugar. And when we see this, like at the end, the reason that when you dab it, you don't get like super high or something like that is there are definitely cannabinoids in it. But what you're seeing at a higher level is a lot of glucose and fructose that made it up to the top that have now begun to form a polyester acyl sugar and burst the trichome. There are some strains that do this more commonly. I know that banana OG that has been grown around here very, very commonly. It's this like a beach sand style trichome head, and they burst all over. It's kind of awesome. But you end up with like super sticky cannabis. If you notice that a lot, it's nothing unusual. It doesn't mean you're misdoing something or anything like that. that is just something that can happen with specific type of trichome heads, and it just means that there were a higher amount of glucose and sucrose going through your plant at that time, so you're probably feeding pretty high sugars and it's making it through well. That's actually kind of cool on a note, because there are nitrogen fixers that we utilize that previously were thought to only work with cane sugar, and then in the last few years they found that they also work with coffee when they were grown in specific places, because those places grew them with such a high amount of sucrose. So really any high sucrose glucose plant can utilize this nitrogen fixer, and it will work with cannabis when you're growing in that style. When you're giving your plant a lot of sugars, you're trying to, you're doing your best to try to give the micro community a lot of sugars, really, because they're what's going to translate it into plant soluble forms and all that. But when you're doing that and you're not overdoing it, then you can definitely utilize these forms of nitrogen fixers. Now, they aren't the only forms of nitrogen fixers. There's a lot of other ones. I mean, most of the time, if you're talking nitrogen fixation, you're talking Azospirillum brasilienase. So like if you've ever seen Extreme Tech Gardening Azos, this is Azospirillum brasilienase only. There are a whole lot of other species, and this is something that people don't seem to come across as much, but there's all the azotobacterias, from Azotobacteria crococum to Vinolandi, all those. As I did say before, I am the person behind Modern Microbes, and as a quick aside, that is one of the things that we really focused on, was trying to make sure that you had forms of nitrogen fixation that worked with the cannabis rhizome and would provide nitrogen in an actual appreciable amount, not just the more minimal amount that Brazilianase will do on its own. So there was a lot of work done in terms of, sorry about that came through there, but there's a lot of work that was done in terms of karyological root surveys and otherwise to make sure that all of the forms of bacteria that were utilized were actually going to associate with the cannabis microbiome. And this is a pretty unique thing. I mean, there's a lot of stuff we've previously had kind of not necessarily misconceptions on, but I guess we don't really understand the full mechanisms behind right now, because when we look at something like Bradyrhizobium japonicum, that's thought to be a legume only associating nitrogen fixer, and yet it does associate with the false nodules on cannabis roots. So there is still a lot to be learned about this plant, like to an amazing degree, and it's showing us more about other plants all the time, or about other diverse systems. So yeah, I don't think there's really a ton more that I had planned on covering in this. I have talked about SSTs, fermentation, a little bit of the more advanced notes with talking about biosynthesis pathways, stuff like that. If you're interested in anything further, you can send a question real quick before I wrap this up. Otherwise, I can make another video anytime. Just send me a message if there's something that's unclear or that you feel would make a good video, and I'm very, very, very happy to cover it. It's always a good exercise for me to make sure that I can give the information in a presentable way. And who knows, I might say something that's completely wrong, and you can send me a message, and that's always good because it means I'm going to learn something new. So other than that, if you're trying to look up for some additional reading, I would really recommend, of course, Teaming with Microbes and Teaming with Nutrients. They're kind of the beginning and introductory reading of coming into probiotics. And then once you've done that and you're a little bit more familiar and you start wanting to go over more in-depth sort of stuff, I really, really recommend becoming comfortable with looking at research papers, peer-reviewed science, and stuff like that. You can use any of your normal PDF readers, although I really like the Kindle for PC reader just because it has the built-in dictionary. If you click any word, it's going to show you the dictionary of exactly that word, and it's freaking great if you're trying to learn something new. Once you do that, look into the studies like preservation of enzymes in the barley malt processing, and look up the cohabitation in the cannabis microbiome. It's another really wonderful study. I hope all you guys have a wonderful day, and I hope this was, if not educational, then at least a little bit entertaining, and have a great day.